Good morning, good afternoon, good evening, and thanks for joining the session on Inside BigQuery BI Engine. I'm Vinay Balasubramaniam. I'm a product manager on BigQuery. I'm joined by Mosha Pasumansky, who's a principal engineer on BigQuery. So in today's session, we're going to give an overview of what BigQuery BI Engine is, why we built it, what is the core value proposition. We go into the internals of BI Engine, and we spend a whole bunch of most of the talk in talking about how BI Engine works. In the end, we'll have some exciting demos to showcase how BI Engine handles higher concurrency. And then we'll have Madeline from Tableau showcasing a demo of BI Engine with Tableau. And we'll have Kevin from Looker talk about how BI Engine works with Looker. So let's get started. So doing BI on big data is quite challenging for customers today. So customers today have to manage multiple data marts around the data warehouse, extract data, manage complex ETL pipeline, to connect their BI tools. And that creates additional management overhead and administration overhead. Secondly, today traditional BI applications are used to extracting data from the data warehouse, creating OLAP cubes, running nightly jobs to refresh those cubes. So they end up looking at the dashboard, which is on old data. More and more customers are looking for not only fast and interactive dashboard, but also they're looking at more real-time data so that they can get insights faster and take action accordingly. And lastly, organization as they scale globally, they want to share their information and insights not only to internal stakeholders, but also to external partners and customers. So that adds a lot of additional concurrency requirement for their BI solutions. These were some of the reasons why we wanted to build the BI engine. If you look at GCP Smart Analytics platform, we provide solutions across all the different life cycles of BI, starting from connecting to multiple data sources, whether it's on-prem sources or software as a service endpoints. We can bring in data from multiple sources into BigQuery. And as part of that transformation, we provide tools such as Cloud Data Flow to do transformation and enrichment on your streaming data. We have Cloud Data Fusion, which looks at traditional ETL style transformation. Then we have Data Proc for Spark and Hadoop sort of workload. Once the data is in BigQuery, you can create a metadata layer to discover data through data catalog. You can use Cloud Data Prep for data wrangling. And then you can connect the data in BigQuery through multiple BI tools. We provide first-party BI solutions, Looker, Data Studio, and Sheets. We also have connectors from our rich ecosystem of BI partners, including Tableau, Power BI, MicroStrategy, and Qlik, etc. But where BI Engine is really helpful is it acts as an acceleration layer between BigQuery and your BI tool. So all of not just Data Studio, other BI tools can use this. So the overall vision for BigQuery BI Engine is to democratize BI by enabling business analysts to perform interactive analytics in real time. So today BI tools compromise between data freshness and speed. So if we want data to be really fast and interactive, it's not fresh. But if you want data to be fresh and latest data without any staleness, it's not fast. With BigQuery BI Engine, we don't want to compromise between freshness and speed. We always want to give you fresh data, and it also always has to be fast. So there are three key value propositions of BigQuery BI Engine. It provides sub-second queries, it simplifies the architecture, and it has smart tuning built in. Let's go into each one. So to achieve sub-second query, BI Engine is a column-oriented in-memory execution engine. It can scale horizontally. So as you have more requests coming in, BI Engine can load balance that request by making copies of data in memory and load balance those requests. And lastly, BI Engine works with BigQuery streaming. So as you're streaming data in, the data is automatically refreshed into the in-memory tier, so you get latest data. In terms of simplification of architecture, BI Engine is built on top of BigQuery storage. So there's no need to extract data out of BigQuery. We automatically move data between the storage tier and the memory tier. And traditional BI tools require you to create OLAP cubes, but we do that automatically for you. That reduces complexity in architecture. And lastly, today BI Engine is available to Data Studio, but what we are bringing to market is BI Engine SQL API, which is integrated with BigQuery API directly. So any of the other BI tools, including Looker, Tableau, Power BI, Qlik, MicroStrategy, etc., can leverage that without having to make any change. on their side. And lastly, there are smart tuning built into BI Engine. So BI Engine has inbuilt cache optimizations, which we do automatically based on your data. And the way you do that is you create a reservation where you specify the location you want the reservation to be, specify the size, and automatically BI Engine takes care of tuning the data based on your query patterns. And all of this data, which is available, is available through Stackdriver. So you can look at how much cache is being used, how much memory is being used, how much of that is coming from cache, how much it's falling back to BigQuery. All of this rich information or metrics is available in BI Engine. So that was a quick overview of BI Engine. Now let's go into how BI Engine works in the internals. Let me introduce Mosha to you to walk us through that.
Thank you, Vinay. My name is Mosha Pasumansky, and I'm very excited to talk today with you about the inner workings of BigQuery BI Engine. So we start with the high-level architecture of BigQuery, and we see three main pieces here. On the left is storage. That's where BigQuery stores all of its data. On the right, compute. That's where query processing is happening. And between them, shuffle layer, which facilitates distributed processing. Now, let's see where BI Engine fits into this picture. We see BI Engine is just another feature of BigQuery. It's not a separate product. So it works on top of the same storage, same network, same shuffle layer, and its worker run alongside of BigQuery workers. Okay, well, if it's exactly same architecture, what makes it possible for BI Engine to get such a dramatic performance improvements? And this is exactly what we're going to talk about now. So we see there are three big pieces, and all three of them contribute to the performance of the query. Storage is a disk I/O time, shuffle is a network I/O time, and compute is CPU. So what we're going to do now, we'll pick each one of those three components and talk how BI Engine makes this time go to zero. Okay, let's start with the disk I/O. And this one may seem to be the most obvious because we just put data in memory and there is no disk I/O. And of course, it would have been that simple if we had unlimited memory and we can put all the data into it. But of course, it's more complex than that. We have to manage and figure out what to keep in memory and what to leave on disk. And that's where the BI Engine Memory Manager comes into picture. This is really the most important piece. It's at the heart of the BI Engine. So let's see how it works. First of all, BigQuery is a column-based database. So we only put specific columns into memory, not the whole table. But more than that, we're not putting the entire column, we're only putting chunks of it. And it works equally well with both partition tables and not partition tables. So even if your table is not partitioned on time and it keeps data going multiple years back, but you're only querying last few days, Memory Manager will figure it out. Next, Memory Manager not only keeps the raw data, it also keeps derived calculations like intermediate results of aggregations and so on. Also, we talked about how BI Engine is always fast and always fresh. So to be always fresh and not to serve stale data, it has very tight integration with metadata service. It knows exactly when transactions commit. It keeps exactly same snapshot timestamps as the rest of BigQuery. So whenever new data comes in, it knows how to pick it up and merge with existing data in memory. Even when data changes through DML operations, Memory Manager knows exactly which parts of it should be invalidated and which should not. Also, Memory Manager knows how to work with load balancing. Even if you have small table but with a lot of querying coming in, it may choose to replicate same data over multiple machines, which is easy for us to do because BigQuery is distributed database. So this way, it will use more memory, but all the queries will still have very fast response time because the load will be spread. So you can see it's pretty sophisticated system. Now let's see what kind of control user have over it. And this control comes in form of BI reservations. BI reservations are very similar to classic BigQuery reservations, but the currency is memory. So you are buying memory and not slots or CPU. All the metrics we serve through stack drivers so the users can understand how efficiently they're using the system. For example, in this picture, you see two lines. Blue one is how much reservation user bought, and the orange one is how much there was used. So user can say if they bought too much and there is too much unused, they can lower the reservation size, and it takes effect immediately. And when they see that the orange start bumping into blue, meaning that the reservation is not enough for the current workload, user may choose to buy a little bit more reservation and balance it like that. Okay, so we covered how we deal with storage component. Now let's talk about compute or CPU. There are many techniques that we use to improve CPU. I'll talk about a couple of them. First one is vectorized processing. So what you see on the left is the classic way how databases the query engine dealt with query processing, which is called sometimes row iterator or tuple iterator model. Basically, it says, query plan comes as a tree of operators, and those operators consume one row at a time, process it, send to the next operator, next row, and so on. So this is very general and very well understood model, but it's not the best one, especially when we deal with column-based data structure and within memory databases. So in recent year, another model called vectorized processing became more popular. Here, instead of reading the whole row and sending it through the tree of operators, we pick single column at a time, read like 1,000 values, process them in tight loop, and then send forward. So this is much more complex model, but you don't need to worry about it because we took care of it. We wrote the entire runtime in BigQuery to use vectorized operators, and we put this new runtime into BI Engine. So there are a lot of benefits for CPU for it. First, the cache locality is much better because you run very localized loops. And second, your code doesn't jump around between operator to operator, so we can fill the CPU pipeline much tighter. We also take advantage of modern CPU instruction called SIMD instructions, which can process many values at the same clock cycle and so on. So we get great benefits from it. Another technique that we're using is we're using many different encodings. So we already have support for a few encodings in our storage system, but now that the data is in memory, we have the liberty of using many more because it's much easier to change them in a memory representation. I will touch a couple of them here. First one is the most well-known one is a dictionary encoding. It works really well when you have table with millions of rows, but certain column has only few distinct values, like maybe 100 or in this picture only 3, and the column is name of the song. So when you have complex expression, instead of computing it again and again over each one of those million values, you just compute it over the dictionary and keep the result. In this case, the result is Boolean, but it can be arbitrary type. Now, this is, by the way, an example of one of the derived calculations that I talked earlier when we talked about memory manager. So the benefit is huge. Instead of doing computation millions of times, we'll do it only 3 times. Dictionary encoding can be used in many other operators, in aggregations, in joins, in analytic functions. So it's a great technique. Another technique is run length encoding. So you can see example on the right here. It works really well when you have same value in the column repeated many times in a row. So here we have example with quarters, and we have quarter 1 3 times and quarter 2 4 times. So again, instead of computing the same expression 3 times, we'll compute it once and just say, oh, and please keep this result 3 times. Now, we have dozens of different encodings, and they can stack one on top of the other. Like you can use both dictionary and TRLE, for example, and many others. So again, BI Engine takes care of it all automatically. It looks at the data, at statistics, at query history, and figures out which encoding is going to be the best. So this is how we deal with CPU. Now let's go and talk how we deal with network. How can we eliminate network or reduce it? So the way we approach it is from the query planner perspective. Basically, we look at the query plans that BigQuery generates, and most of those plans are distributed plans. And then we say, okay, how we can improve it, given that we have this BI engine with its stateful workers and different scheduling policy and in-memory data. So let's again pick a couple of examples. What you can see here is a very simple aggregation query. And the distributed plan in the classic BigQuery will be two stages. First stage will do some filtering and then do preliminary aggregation and will compute intermediate results. Then we'll send them all over the network to compute the final result. Okay? With BI Engine, here's the plan with BI Engine. So it's funny because it looks almost exactly the same, but now instead of doing distributed plan, we're running parallel plan. Basically, our scheduler knows where each piece of data resides on each worker, can bundle them together and say, run the same plan, but this time not over the network. Run it as a parallel plan. Okay, do this local aggregation locally, and then also merge the result also locally. And now only after that you can send it to the distributed execution. So network traffic is reduced greatly. Let's look into another little bit more complex example. So here we're talking about joins. And there are many join plans in BigQuery, but one pretty popular one is called broadcast join. It works very well when you have a big table, let's say a fact table, joining with a smaller one like dimension table. So typical plan in BigQuery would be to take this small table and broadcast into all workers. And broadcast goes over the network. Now, what we can do with BI Engine, memory manager can look into it and say, you know what, this small table is small enough. Why don't I just replicate it across all of the nodes which have the pieces of the fact table? So it will use a little bit more memory, but now join can happen completely locally, right? We don't need to use network at all. Okay, so this kind of decision memory manager can do because it knows the reservation size, it knows the query workload, so it can do this kind of automatic tuning. Okay, so now we covered all three big components of BigQuery architecture and talked a little bit how we improve each one of them, and it's time to see this, how it actually works. We're going to show you three demos. We're starting with the first one to demonstrate how BI Engine handles high concurrency. And this is artificial demo which we simulated, and it simulates the following situation. Let's say you have a company and you have table which is multi-million rows table in this example, in this demo, and we have many business users and analysts which need to work with this data. So let's say they all have complex dashboards, and dashboards have many visual elements. So we simulated single dashboard sends 10 different queries. Okay, and we also said dashboards are not static reports. People work with them. So we said, what if each one of those users changes dashboard once every second? I'm saying, this is kind of very unrealistic. Nobody will change it every second, but we say, let's push it. Okay, so many users with dashboards, each dashboard sends 10 queries every second. So what we're looking here is a stack driver, which captures few metrics. First metric we're going to focus on is this blue line, which shows the throughput measured in QPS. And we can see that we're starting with 100 QPS, which roughly represents 10 users sending 10 queries each every second. All those queries are completely randomly generated. They're not the same. There is no reusing same query result. It's truly BI Engine working full speed. 100 queries a second. Actually, 100 is too small. You know what? Let's increase it to 1,000. Okay? Okay, you see, we're working with 1,000 now. It's like 100 users working with those dashboards. Let's ramp it up. How high? Okay, 2,000. Now, 200 users every second, 10 queries. system is working. But now how well is it working? Maybe it's falling apart. So to see how well systems scale, we would need to look into different metric, which is query response metrics. And you see those 3 lines at the bottom of the chart. It's kind of hard to see because the kind of very low. So let's zoom in into them. Okay. So those 3 lines represent the percentiles of query response. The lowest one, which I think is orange, shows the 50th percentile, which is medium. Okay. And then the next one is red. It shows 95th percentile because it's also very important to look at tail latency in large scale systems. And finally, the blue, rather violet one is the 99th percentile. So first thing that we observe is no matter how far we ramp up our query load, they stand largely horizontal, largely the same. Maybe at 2000 QPS they increase, but only a tiny bit. Also, absolute times are really good. Like 50th percentile is only 35 milliseconds. 95th percentile is lower than 100 milliseconds, and 99th percentile is 150 milliseconds. Remember, this is many million rows table, and we're running at 2000 QPS, 2000 queries every second. So we can see that BI Engine holds really well. So that was throughput demo, and I'm passing it over to Vinay to show 2 other demos.
Thank you, Mosha. And as you saw, how BI Engine is able to scale much more higher to provide higher concurrency. Now, I want to introduce Madeline Corlini, who's a product manager in Tableau, to showcase an initial preview of how Tableau and BigQuery BI Engine works together.
We're going to start off in Tableau Desktop. And the first thing I'm going to do is I'm going to connect to my Google BigQuery instance. Then I can choose what data I want to analyze today. To leverage BI Engine, all I need to do is ensure I connect to the billing project where BI Engine is enabled. Then I can select the project and dataset where my data lives. I'll then pull out the table or tables that I want to analyze today. Hopping into our first sheet, I can pull out the number of records field to quickly see that we're working with a data set of over 87 million rows. That's a pretty hefty data set to work with. Now this data contains lots of customer reviews of various health and beauty products sold by a company called YLM. I can use Tableau to quickly aggregate the overall reviews for all of these products. Looking at the average review, I can see what of our products have scored very high and which ones haven't scored as high. Tableau also makes it easy to quickly switch between various visualization types. Let's call this product reviews. Now each of these products lives in various different categories. Tableau makes it very easy for me to group these various categories together into something we call a hierarchy. I'm going to create a new hierarchy called product. And by doing so, it makes it easy for me to drill up and down between various levels of granularity in my data. Now for this view, I'd like to get a sense of the overall quantity of sales I have for each one of my categories. I'd also like to add the context of the average rating as well. Now every time I use aggregate rating here, I'm typically going to want to look at the average overall. So I'm going to set the default property to use average. I also want to change the color scheme as well. I want to make sure that I don't miss any of these products that may have lower reviews as I go through my analysis. Now I can see that there are certain product categories where I have a high quantity of sales, but the aggregate rating isn't very high, and that might be something I want to investigate. Let's call this product reviews and quantity. I'd also like to look at this data geographically. This dataset already includes state information, so I can simply drag state out onto the view, and Tableau will plot that for me. Now I can also add quantity as well, so we can see which states have higher quantities sold. I'm going to add aggregate rating to the view again, and I can see that generally the states where I have higher numbers of sales, I also typically have better product ratings. However, there are some problem areas that I may want to investigate. I can easily drill down to a lower level of detail to figure out if there are specific cities where I have high quantity but low ratings. Let's bump up the size a little bit so it's easier to see. We'll call this product ratings and quantity by city. Finally, I want to pull together all of these visualizations onto something we call a Tableau dashboard. Using a dashboard makes it easy to compare multiple visualizations at the same time. It also gives me the ability to add interactivity between these various worksheets. Doing so effectively creates an interactive application that lets me visually explore my data. I can look at some of our problem subcategories and select a particular region to explore in more detail. And finally, I can pinpoint exact products that have low reviews. And so with that, in just a few minutes, we've built an interactive dashboard on top of over 87 million rows of data, thanks to BI Engine. Now I can publish this to Tableau Server or Tableau Online and share it with other people throughout my organization.
Thanks, Madeline. That was a great demo of how Tableau and BI Engine work together. Now I want to introduce Kevin Marr, who's a product manager in Looker, to talk about how Looker and BI Engine work together.
Hi, I'm Kevin, a product manager at Looker, and I'll be showing you Looker's integration with BigQuery's BI Engine. First, Looker is a modern data analytics platform that operates in database. This means that Looker does not ingest your source data. So when you load a report or visualization in Looker, a SQL query is being sent directly to your data warehouse. And as you can imagine, having a very fast data warehouse means that you'll get a very good experience in Looker. So I'm in Looker's Explore page, which allows business users to self-serve by exploring their data, building their own visualizations, and ultimately answering their own questions. The Explore page is powered by Looker's modeling layer called LookML, which provides an abstraction layer between your database schema and the business terms that your users are familiar with. All I have to do to build a query here is select dimensions and measures and add filters. Say I want to know the total revenue we've ever made in our fictitious e-commerce store. I can just click on the total sales measure and hit run. But behind the scenes, Looker has generated a query, a SQL query for me, and has sent that to BigQuery, in this case BI Engine, and has given me the answer, in this case $9.6 million. It's easy for me to add things like filters. Say that I want to look at this over some constrained time frame. I can click on a filter. I can pick, any of these easy point and click options. I'll just pick, say, I don't know, April 2020. So starting on the 1st of April and ending on 1st of May. As I've done those interactions with the user interface, again, Looker is adapting the SQL to reflect what I want. And when I hit run, that SQL gets sent to BigQuery's BI Engine, and the result is posted here. Great. So in April 2020, my business made $441,000. Also, if I jump over to the BigQuery console, we can take a look at those queries, and you just get a sense for how fast these queries really are. If I click on this, you can see that that query I just ran took only a quarter of a second. Now let's take it a step further, and maybe I want to create a visualization. Maybe I want to create a time series. I can do that just by adding the date dimension to my query, again, hitting run. Looker has adapted the SQL. and the result is displayed here in Looker's user interface. If I want to visualize it, I can just open up the visualization section where we have a myriad of viz types. In this case, Looker thinks that a line chart is the best based on my data, which I like. And I'll go ahead and save this to a dashboard. I have a nice little test dashboard I added. I'll save it there, and I'll pop that open in my other tab. I'll go ahead and refresh this dashboard just to rerun these queries. Again, we've turned off all caching on this demo just to show off the query speed in BI Engine. Looks like the dashboard's done rendering already. And at the bottom, I can see my new tile. I actually added two from my previous recording, but pretend it's just one. Dashboards in Looker are also designed to be heavily interactive. So say that, right now we're looking at just the data over Facebook. I can deselect that selection, and that'll cross-filter across all my other queries. And I can see the data broadly across all the demographic profiles. I can also adjust filters directly in the top. That I want to look at this specifically in some city, say, San Francisco, where I live. I can start typing that in, and Looker will start offering suggestions based on my underlying data. So I can click that, rerun the dashboard, and see how this is trending just in San Francisco. Great, that's it. Thank you very much.
Thanks, Kevin. So in conclusion, right, BI Engine is available today. You can try it today with Data Studio. It's a GA product. It's available today. But what we are really showcasing here is how BI Engine SQL API makes it possible to work to get the same acceleration, same benefits with other BI tools, including Looker, Tableau, and other BI tools who work with BigQuery directly. So that's coming sometime end of this year. We'll have an initial preview. And also there are additional sessions to learn more about, if you want to know about how BigQuery is evolving in other areas. There is a session DA2 and 200 which talks about BigQuery's roadmap. And if you want to learn about how Looker is evolving and with their roadmap, there's session DA239. So do watch out. And again, thanks for joining.